Okay, welcome to Chapter 9, page 245. I talked about storing data in Windows Server. So, learning objectives, understanding the storage technologies, the connections and the devices, understanding RAID, a redundant array of inexpensive disks, and understanding disk types. Okay, so understanding the storage technologies is the first part. We're talking about a physical interface, a mechanical thing, and disk controllers, where the disk controller is and how smart it is. The storage media itself, and then the storage types. So let's talk about different storage types first, page 245. Optical discs, you guys know what all this stuff is. CD-ROM and Blu-ray and all DVD. And most of them are read-onlys, really. Yes, you can get, I have a Blu-ray reader, right? I have a DVD writer, CVD, reader and writer, but quite frankly, it's so slow to write to one of these guys that I can't imagine anyone doing it. If you're making a movie or something, great. But I'm talking about just using it as general purpose storage? No, probably not. Then we have the traditional hard drive, the actual honest-to-God spinners. And these guys are getting kind of few and far between now because the storage technology just passed them up. They have very large capacities. You can get a spinner at 60 terabyte now. Good grief. And they have relatively fast read and write speeds, but not compared to, not anywhere near compared to the direct attached NVMe SSDs. Okay, so we're not even in the same league. We're not even in the decimal point read. Most hard drives can read because of the storage interface, using like SATA as an example, like 600 meg. That's about it. You can get 3,000 meg in an SSD. And then the other thing that makes them kind of thing is access time, because in an SSD, it can jump from one spot to the memory, another spot instantaneously. But a physically rotating drive, the head has to move. It takes some time. So there's a latency issue in access time. Average access time on a hard drive, a physical hard drive, would be pretty low. So obviously, solid state disk, very, very fast, and practically no access time at all. So access time is just non-existent. There's other, floppy drives and tape decks and things of that nature. I still have one machine that I plug in a USB floppy drive occasionally, USB CD-ROM, because most of the cases these days do not come with any 3.5 or 5.25 inch slots. That just shows you how unpopular these things are. So let's talk about NVMe one more time. This is non-volatile memory express, and it's not really in the... So it uses the mechanical standard called an M.2. Now, don't get too confused here, because the mechanical standard does not tell you what the device is going to be. All it has is, if you buy a storage device, make sure you're getting the one that actually is NVMe and not a SATA device. Yes, you can get a SATA drive in an M.2 configuration. It just has a different little cutout on it. So it's a mechanical drive. A mechanical interface is not... it is mechanical and electrical, but my point is it's not dedicated to one of these guys. And they come in different lengths. In M.2, it'll tell you the length of the card that'll fit into it. Most of these guys can use up to 4 PCI lanes. And if you don't know what that is, that's okay. Basically, it's the interface that the machine uses to interconnect all of its peripherals, everything. So if you have a graphics card, you could have 8 PCI lanes. So typically these guys use 4. And in today's normal, relatively new PC is going to have a PCI version 4. Obviously I've got a newer one. It does 5, but it's okay. Not that big a deal. With 4, you can get about 7,000 kilobytes per second across the bus with using all 4 lanes at PCI 4. So that's a lot. And that's probably even more than what the actual device can handle. It probably can't handle 7,000. It probably can handle 4,000 or 5,000. So the interface is fast enough to keep up with the devices that you're buying. Cool. So let's talk about the adapter and the controls that typically this is going to be built into the motherboard, so you're not really going to have much choice. But a serial attached ATA, that's ribbon cable. You know, the parallel ATA uses a ribbon cable. No one sees any of that anymore. But you do see SATA drives, and I have, most motherboards have like 4 or 5 SATA drives, maybe even some external, an eSATA drive, a port in the back which you hook up to a cable to hook up to something. That'd be kind of cool. And then SCSI interfaces, small computer serial interface. Anyway, the idea is that SCSI drives are still around. Servers still use SCSI drives a lot. I don't have any at the house, but there's a kind of a cool one out there that's a serial attached USB. So it's basically kind of sort of a SCSI interface onto my USB drive. So I have a relatively new flash drive, and it uses the SCSI interface to USB. So SCSI's still around. It's just not. So when you purchase a disk, you need to know the interface that you're buying. So you probably can't go to Best Buy and get a spinner. I mean, well, no, that's not true. You can't. But they'll be monstrously huge guys. So you need to, when you're purchasing a disk, you need to know, what the interface is on the guy. So Parallel Advanced Technology PTA, that uses that old 40 ribbon. I haven't seen one of those in years. Uses a Molex power connector. Molex is just a brand. So you plug a drive in and you plug this guy in. Serial ATA, 7-pin cable, 15-pin power connection, and there's some rather significant limits on the cable length. I mean, you can't really go, like a meter or something. The SCSI, those are mostly for enterprise disk, and I have seen those guys. There's actually another type of SCSI, but it's serial attached SCSI, SAS. It's just so when you buy one of those guys, it's designed. It has the exact same pinouts. So again, when you're buying drives, you can't just look at the ass end of the disk and go, these two are the same. No, one might be SCSI, one might be serial attached SCSI. Okay, so the whole point about serial attached SCSI is some of the processing power is moved from the disk controller to the disk itself. So it just splits up the speed at which things happen. So it's those are very expensive. And again, if you're not in the server world, you'll never see this. But PCI and PCIe, so on page 248, that's the industry standard. We started out with the ISA bus. It was just a 16-bit bus, right? And then we had the peripheral interconnect PCI, which had both 32 and 64-bit. And now we're at PCI Express, where all the slots are the same. Well, it's not physically the same. I mean, you can have a big slot, like a PCI 1 slot. So it's all about the number of lanes. So this can take 4 lanes. This one can take 8 lanes. That kind of thing. So for your graphics card, you want to use 16 lanes. If you have 16 lanes, that kind of thing. Okay. So 4 lanes, 16, and 8. And PCI version 4 is still the most common around. I mean, I have a PCI 5. Quite frankly, I don't have anything plugged into it that would make a difference. I mean, I do have my hard drive, my main C drive on my machine, plugged into a PCI, V5 slot with obviously not only does it have the slot has to support PCI 5, the device has to support PCI 5 as well. So cool. Anyway, so V5 is here. It's just not very prevalent yet. So let's talk about local storage. So storage devices that are directly connected to your machine, right? That kind of makes sense. Mostly in the same enclosure, not necessarily, but most of the time, all your storage devices are plugged into the box. And then we have direct attached storage. So this is just like at home. Your internal disk is connected directly to the motherboard, right? You crack open the case, you plug this guy in, and so direct attached. And some direct attached storage could be used for BitLocker. Now, BitLocker is the internal thing that Microsoft uses to encrypt your hard drive. And particularly if you have a portable machine, that would probably be a good thing. At home, I don't use BitDrive on my machines at home. If somebody wants to come in and, break into my house and steal my machines, I'm not saying it's okay, but I don't use BitLocker for that. BitLocker is for oops, I left my thumb drive, or oops, I left my laptop in the back of a cab. That's the thing that I use that for. So there are other types other than just direct storage stuff. So storage that are in separate containers, separate enclosures. Network attached storage, NAS. So a NAS box basically connects to the network. It doesn't connect directly to your machine. So it acts as a server. So you don't have to install like Windows Server on it. It automatically acts as a server. So your server can get to it and all my clients can get to it. This is typically what I would have at home, for example. It's very easy to set up. Basically, you just plug it in. It uses a web interface once you got it plugged in. Uses a normal, Ethernet, RJ45 connector. I have mine at 2.5 gig since all my devices in my house are at 2.5. And every PC you can show up at, and it shows up as if it was a server. In fact, well, I can't show you that because we're crazy here. So every PC can see it, and if given permissions, everyone can go and read and write to these things. It's great. It's a good way. That's how I do my. For example, I'm recording this guy right now, and so since recordings can be kind of huge, I store them on my NAS box, so I don't have to deal with it because I have practically I got 70 something terabyte on my NAS box, so I don't have to worry about running out of disk space. I use normal. I have a C and a D drive on my main machine, and they're like 2 terabyte maybe here and 1 terabyte there. I mean, I don't keep I do production stuff there, but I don't keep things there. Keeping things I put on my NAS box. Okay, so there's a kind of a cool web page here that talks about why NAS for home. It's a pretty good thing about customizing and accessing files and backing up your stuff and guaranteeing data. So you can set up an automatic backup on all your client devices that just point to the sky. It's kind of sort of almost like how OneDrive works. So you basically have a private OneDrive. Wouldn't that be kind of cool? So all your stuff gets backed up. So if anything happened to your machines, you could blow it all away. Now I kind of do the same thing. Hang on, I got a noisy cat. I do the same thing. I do my backups of all of my machines, and I just do an image backup. I don't use one of these things. An image backup once a week, and I just pop it on over. Because again, I got 70 something terabyte. I don't care. I don't keep. It's archive stuff. Okay, and boy do I use it. Okay. So this is a good way, and it's cheap. These guys are not expensive. In fact, you can get free NAS. It's a company. If you have an old machine someplace, maybe even a Raspberry Pi, you can plug a couple of hard drives into this guy, run this thing called free NAS, and you could be up and running with practically no cost whatsoever. If I was just to go to Amazon and just type in NAS, I could probably end up with a gazillion. Okay, so a 2-bay is like $200. Here's a 4-bay one, Synology. Anyway, so here's a good these things are relatively cheap. By the way, this is what I was talking about. There are some hard drives that are specifically designed to work inside NAS. They've been especially tuned. Western Digital has a red brand for doing that. Here's one from Toshiba. Okay, we're coming up on the 15-minute mark. You guys know how this works.